Welcome back to another Vectors EDU webinar series. Today we're going to be demystifying survey styles. I know this can be intimidating for some out there, but I think it's important to cover a couple of examples. What we're going to do here is pull up Trimble Access, and we're going to run through a couple of examples, create a bunch of survey styles, and hopefully answer any questions you guys may have. We're going to run through RTK and infill, some other static applications, as well as some of the options regarding total stations. Stay tuned. All right, so the first thing I'm going to want to run you guys through is where to find your survey styles. So on the emulator here, simulating one of the Windows 10 data collector devices. And the first thing we're going to go do is hit our hamburger button in the top left-hand corner, come down to Settings, and then Survey Styles. So these are kind of the defaults. If you guys are on a newer device, these are the default survey styles that'll be in here. So first thing I want to run through is a standard RTK survey style. There is already one in here, so we'll go ahead and modify this. So in our RTK survey style, we do this a lot with tech support when dealing with issues with radio link. I always like going into survey styles because this is what kind of establishes how things are connecting, communicating, and typically this is also where most mistakes happen. So I prefer going through this top down. So first thing we're going to jump into here is going to be rover options. So because this is a RTK survey style, obviously our survey type is going to be RTK. These are some of the other options we're going to go through and cover, but because this is just a real-time kinematic survey style we're creating, we are going to leave the survey type as RTK. Next thing looking over here is broadcast format. So you can see we have a multitude of options. CMR, CMR Plus, and CMR-X are, if you will, the standard for Trimble equipment. Whether there's a plus or X or CMR with nothing after it here, this is your compact measurement record. So all this is saying, the difference between these three is going to be the compression level. So CMR, when we only had GPS on board or the GPS satellite constellation, we didn't need to compress records as small because there wasn't as much data going from the base to the rover through your radio link. Now with our newer equipment, R10s and R12s and R8Ss and all these other great receivers available today, utilizing GLONASS and some of the European constellations, and with L5 coming on board, there's a lot more raw information coming across. So with regards to broadcast format, if you guys are on a newer receiver, recommendation is to stick with CMR-X. Again, we're talking about the rover here. So what this is determining when choosing this, my rover that I set up in Bluetooth is going to be looking for a CMR-X correction packet. We'll have to make sure whatever you pick for your broadcast format for your rover, it needs to be the same as the base. And again, I'll come back and hit on that. Antenna here, this is going to be which receiver you're using with your RTK survey style. If by chance you pick the wrong one or this is incorrect, whenever you set up your Bluetooth settings and actually go to start your survey and hit measure RTK, it'll tell you, hey, we noticed there's a mistake based on your Bluetooth settings. Do you want us to correct and update the survey style? So that can be fixed after the fact, but obviously it's preferred to have things chosen correctly from the get-go. That's why we're going through this. So for this example here, I'm going to put this as an R10 Model 2. And again, your measurement height here. R10s are measured to bottom of quick release. One of the things I do like doing, I try to make things plug and play. If I'm on a 2-meter fixed height rod, you can go ahead and put in your antenna height for your rover. It's one less step you have to do. Serial number, I do know a lot of people prefer to type in the serial number. I actually prefer to leave this blank. It really doesn't matter because this is being determined through your Bluetooth settings. So I never bother with filling out the serial number. Use station index. This is something we see a lot. A lot of people will actually key in station 0, station 8, and then in their base options, they'll go ahead and pick their station index. I prefer to leave this as any because I like knowing if someone else in the area is then jumping on my frequency, or I know before I get started if I'm going to have issues with other people walking on me. And then of course with that, I always have prompt for station index. I like knowing if there's other people in the area. Satellite differential, we're going to leave off by default here. We can pick an option here for SBAS or utilize the OmniStar. Satellite differential by default will be off. Elevation mask by default is 10 degrees. This is above horizon, what satellites to ignore. If you guys are working in some deeper canyons or some real deep terrain, or using some stuff with permanent base stations, there's some other unique situations where sometimes this does need to get bumped up. I prefer to leave it at the default of 10 degrees in the survey style. And when I actually conduct the survey, when I get back to Trimble Business Center, if I need to make some corrections to tighten up some precisions or ignore some bad satellite data, we can always tweak that after the fact. So elevation mask is simply what satellites will be ignored and or accepted as part of the solution. So this is stating 10 degrees off the horizon. I'm going to be observing or using all satellite signals coming in as part of my solution. PDOT mask, this is simply strength of geometry. So as the satellite constellation is moving overhead, there's a calculation that basically tracks the geometry of those satellites and how reliable that signal and or your position is. By default, this is at 6. I prefer things to leave at 6. If you guys are ever out in the field and hear bad PDOT, it simply means you've exceeded what Trimble deems to be acceptable with the current firmware and technology that they're running. Last portion coming in here for the rover options is which satellite constellations we're going to track. You guys can enable all of these. Some of them you're not going to get. Galileo, we will have some floating over. GLONASS obviously is going to be our Russian satellites. L5 on the newer receivers. This comes in play with the R12s. I know we're going to do some specific videos on that in the future. But for me, on a typical RTK survey style, this is my preference to utilize GPS, L2C, L2E, GLONASS, and L5. Roving precision, down here we have auto tolerance. We can set our tolerances, what's acceptable. Maybe you're in a little bit of a challenging environment and hey, we want to accept something maybe if we're just doing kind of a natural ground topo over a large field. Hey, if precisions kind of get a little bit looser, but that's acceptable to us, we can come in here and tweak these, or we can leave auto tolerance on. And then with the R10s, we've got tilt functions. This would be the electronic bubble. We can enable or disable that from this location here. Again, this only applies to the rover. And then we have exfil technology, and this is specific to the R10s, essentially where you lose your radio signal. We can utilize exfil to kind of backfill in that lost radio signal, and you can still take a couple of measurements. I know we'll be doing a specific video on that because it does get a little interesting and hairy there. I'm going to go ahead and accept this, and that will cover our RTK rover options. All right, continuing on down the list, now we're going to go ahead and jump into Rover Datalink. Because this is a RTK survey style, we will be receiving our correction via UHF radio. So type here, obviously, we're going to choose radio. Internet connection will be VRS, which I'll talk about here briefly in a moment. So again, for RTK, Rover Datalink, type it needs to be set to radio. And then which radio is actually being used to receive your correction. Because it's the rover, we're going to do receiver internal. It's also a good reminder, make sure you have your rubber duck antenna screwed onto your rover. Can't tell you how many times people have had radio link issues and they forget to put on the little rubber duck antenna. So this is simply saying, hey, we're not using an external radio at the rover, we're using the internal radio itself. Here you can connect to the rover radio to pick your frequency. We're not going to do that here. We're just going to focus on the survey styles. So if you've got radio and receiver internal chosen, we can go ahead and hit accept. Again, continuing to work on down the list, we're going to go into base options. Here, because we're doing plain Jane RTK, survey type again, we're going to leave as RTK. Broadcast format, like I discussed earlier, it needs to be the same as what you chose at the Rover. So CMRX, this needs to be in common with what is set under your Rover options. So we'll do CMRX, which antenna or which receiver we're using. So for this, we can simulate something here. We can call this a R8S internal. Our measure 2 on any of the R series, R8s, R6s, I prefer to measure to center of bumper. Antenna height, obviously, we're going to leave blank. This gets filled out when you guys start your base survey. Serial number, as discussed before, I also like leaving this blank. This is determined from your Bluetooth settings. Station index, you can put in any number you want to here. This just designates which base yours is. So when it prompts for station index after the base is started and you connect to the Rover, you'll see this station index show up. Elevation mask, same as the Rover options we went through. I prefer leaving that at 10 degrees. And then signal tracking. So for this R8S we're simulating here, GPS, L2C, GLONASS, and if this is a triple frequency receiver, I would go ahead and turn on L5 here as well. If L5 is not chosen, or let's say GLONASS here is turned off, but it is turned on at the Rover, these need to be in common as well. You can have the Rover set up for L5, Galileo. You'll see all, when you connect to it, you might see 20, 30 different satellites. The only thing that's going to be used in your actual solution when you measure your point is going to be what's in common. So whatever the base here has for satellite tracking, again, if this is a triple frequency receiver here, and the Rover has the same options set up, it'll use what satellites are in common to take your measurement. So go ahead and hit accept here. And let's jump on down to base data link. All right, so here in base data link, we have a couple of settings I want to go over here. Again, this is going to be set to radio because we're sending our correction via UHF. This is not a VRS survey style, which would utilize the internet connection. So this is going to be selected to radio. This is which radio are you using at your base station? I'd say 90% of you guys will be using a TDL 450. There may be a very small percentage still running older HPB 450s or possibly the Trim Mark III. Most of you guys will have this option chosen here. Next thing I want to cover is the receiver port. I would say 90%, 75 to 90% of the tech support calls we get where there's, hey, I can't get radio link at my Rover, is because of this setting right here. Default for Trimble receiver port is set to 2. What this setting is where do you want the base to flow data, raw data out of, or your correction data out of. So if you flip over an R6 or one of the R8s, you'll notice there are 2 ports on the bottom side. There's a round 7-pin LEMO port, that is port 1. On the opposite side, you have a 9-pin or a RS-232 connection, that is port 2. I would say 95% of you guys are all flowing data, or which cable configuration. You have a 7-pin LEMO, the round connection plugged into the bottom of your base that then is plugged into your radio, and you've got a little pigtail that comes off that you're plugging your battery into. So again, this is the setting I probably see wrong the most when doing technical support calls, is this is chosen as port 2, whereas the cable that's actually plugged into the bottom of the receiver is the round 7-pin LEMO. You need to tell the base here, we're going to flow data into port 1 or flow data out of port 1 that then is plugged into the TDL. So if I've got this chosen, the last thing I want to cover is this baud rate. So here we've chosen we are going to flow data via radio to a TDL 450. We're going to flow that data out of port 1, the round connection, and the rate at which we're going to flow data is at 38,400. This is the other setting I see wrong all the time. People will think this is the over-the-air baud rate. This is not. This is how fast we're flowing data from the base through the cable to the radio. If you look on your TDL radio, you'll see two kind of baud rate settings in there. If you scroll through your screen, there is a option for serial baud rate. You need to choose 38,400. So that serial baud rate you see in the TDL needs to match this setting right here. Again, this is the rate at which we're flowing data from the base through the cable to the radio itself. Then, of course, on the TDL radio, you'll also see baud rate. This is referring to your over-the-air baud rate. That is what you guys probably are needing to set to the 9600. Hope that makes sense, and we'll move on to the next one here. All right, so that pretty much covers our RTK survey style. The settings we went through went from RTK Rover options down to our base Datalink options. Obviously, there are a lot more settings in here. I know we're going to be coming out with some additional videos. Topo point, observe control point, kind of down here through continuous topo. These are some small setting tweaks you guys can make, determining how many epochs are recorded for each observation. Stakeout, we have a lot of different settings in here regarding how your data is being viewed. I know we'll be doing a specific video on that, as well as a site calibration class coming up. At this point, kind of wanted to take a quick pause. We are going to move on to the next survey style. So for those of you who have fast forwarded to this point and wanting to learn about doing a RTK and infill or RTK and logging survey style, what you guys will want to do is watch the RTK video. And then from this point moving forward, I'm going to show you what changes we're going to make to the RTK and logging survey style. So I'll go ahead and get right on into that. All right, so back on our main survey style page here, here's the RTK style sheet we just went through, and we made all the appropriate changes. So knowing that our RTK survey style is good, the next one I want to create is a RTK and logging. So rather than have to go back through every one of those settings we just went through and kind of cross-check and make sure everything's the same, one of the things I like to do, if it's highlighted, you can go ahead and hit copy down here at the bottom. We can give it a name. So now these two survey styles are exactly the same because I copied all the settings from RTK. I've now applied them with the new name I've given it. So all we need to do now is open RTK and logging, and we can make the appropriate changes. So if we're wanting to collect a static file to submit into Opus and log raw data at the base, we can leave every setting that we went through on the RTK portion, and all we need to do is come into base options, and under survey type, technically it is still an RTK survey style, but we can do RTK and logging. So again, this is under base options here. The only change we need to make is change the survey type from RTK to RTK and logging. As you can see, all the settings we went through previously are still the same, but we do have a couple more options here. This is where things have changed, and now we have the option to pick which logging device we're going to record our raw data to. Obviously, because we're going to be walking away from the base station once we get the survey up and running, we're going to want to log our raw.to2 file to the receiver. I've seen people choose controller, which works great for about the first 30 seconds till you walk away from the base and you've broken the Bluetooth connection, and now your static file is corrupt and you won't be able to submit anything to Opus. So again, anytime you're dealing with the base, always make sure you choose your logging device for the receiver. Our next option here is we can pick which logging interval. Different customers have different preference on this. I will leave this up to you guys. I always find more is better per se, but that's not always the case. If I'm doing a shorter 2-hour session that I know I'll have to submit into Opus, I go ahead and log it 1 second. But again, you're going to be post-processing this if you're submitting it into Opus against other core stations. those course stations may not be recording at a 1 second logging interval. It might be 5 seconds, 10, or 15. What you guys need to be aware of is it's only going to post-process that data for what's in common. So even if I set my receiver to 1 second and I'm post-processing versus course stations that only record at a 5 second interval, it's only going to use what's in common. So for me, I always like to record a little bit more, knowing, hey, if I don't use the extra, no big deal, but I'd rather at least be able to meet what's in common with what I'm post-processing against. I especially like leaving this at 1 second when doing larger control setups where I'm doing multiple sessions at the same time off multiple receivers. I always find having more data is better because if I need to crop out some noise, I have that ability after the fact. So again, just to recap, we did change survey type from RTK to RTK and logging. We didn't make any other changes other than picking our logging device and what interval we're recording at. Everything else here is the same. You do need to make sure you hit store. So now we have our 2 survey styles created. We have our RTK with external radio, and we have RTK. This is also with an external radio, but we've added logging functionality. So with that in mind, in the copy function, which I really like doing, so you really only have to make one survey style, then we can simply copy it and make the setting changes we would like to for our new survey style. All right, so the next survey style I want to jump into is a RTK still base Rover, but I want to utilize internal transmit off of the receiver. So for those of you who might have an R10 as a base receiver, you guys can go in and set that up for a 2-watt transmit or a half-watt transmit. Or those of you guys with R8Ss or R6s or R8s that have the code or functionality to do so, rather than having to set up a whole nother tripod, pull out a big battery if you guys are doing a small site, it's real handy to be able to use the internal radio to transmit your correction, and you don't have to set up all that extra equipment. So because our RTK survey style here, all of our settings were correct and things looked good when we ran through that at the beginning of the webinar here, the only change I want to make is RTK with an external radio. I want to it would be beneficial to have a survey style using the internal transmit functionality from the base receiver. So I'm pointing that out because it's the RTK survey style that we want to create a copy of, not the logging. So if this is highlighted, I can hit copy. You can name these however you like. You can always expand this column out if they're hard to read. It definitely helps on the bigger devices. There we go. You can put more in here, so it kind of spells it out, especially if you guys hand off equipment from one crew to the next. So we've got our RTK and logging we just finished creating, and we've copied this survey style to create an RTK and internal transmit. So if I jump into here, we really only need to make one setting change similar to the last one we just went through. This would be regarding our base functionality because we're not changing anything on the Rover end. What we are going to go into is base data link. We are still going to be broadcasting UHF, so 450 to 470 megahertz. And what we are going to change is we're no longer going to flow data through port 1 to our TDL. We're simply going to transmit over the internal radio on the receiver. For those of you with an R10, Model 1, Model 2, and even the R12, you guys should be able to go into Connect here where then you can see some additional settings. I don't have a receiver hooked up at the moment. You should be able to change it from a half-watt to a 2-watt transmit. Here you can also change some station ID and some different functionality there. So again, the only change we're really going to make here is change this from our TDL 450. Our base is now going to be using the internal radio. You can simply hit accept and hit store. All right, so now we've got our 3 survey styles created. We'll go ahead and run through this next one. I do think it is a beneficial survey style to have in here. We can create a copy of our RTK with external radio and logging. We can do the exact same thing, but basically add the internal transmit option in here. Again, you can name these however you would like. Oh, I have to hit accept. So we've got a normal RTK and logging with an external radio, and here we've got an RTK internal transmit and logging. So again, only things that change are going to be on the base end. So just to confirm this, so you guys can see it, we are still RTK and logging to the receiver at a 1 second interval at the base. Can hit accept. Base data link, because this we made a copy of our standard RTK and logging, it is going to show the TDL 450. And just like we did a moment ago, we can change this to receiver internal, hit accept, and store. So these are the primary 4 survey styles that I like having created in any data collector going out and about. This does give you a lot of flexibility. Again, most of your, I see a lot of customers who have R8S and R2 different Bluetooth setups, so there might be 15 or 20. I think that complicates things, and personally I prefer just to have these 4. This gives me a lot of different options based on the job site I'm going out to. Again, when you guys are in your Bluetooth settings here, if you're changing different receivers, just make the change here. So you might have a list of 8 different receivers based on your company. Again, you'll have the same list over here on the base option for which receiver to connect to. I don't like having individual survey styles for different partnerships for equipment. Me personally, I prefer just to have these 4. And again, we set these up with an R10 Model 2 for the Rover and an R8S for the base. If you guys change your Bluetooth settings, but you go in to start a survey under RTK and internal transmit, for example, it'll tell you, hey, your Bluetooth settings, it's different than what you have in the survey style. Do you want to hit update? You can just update the receiver. It will go in automatically and change this right here. It'll change this to whatever receiver you've connected to. So again, for me, I'm not going to hit store here. These are the 4 primary GNSS survey styles that I like having in my data collector. The next one I want to jump into is going to be a fast static option. So this works out really well in the instance you might be doing RTK and logging. You're working on a larger site, and let's say you've got 1 more section corner or 2 more quarter section corners you guys need to take an observation of. So I might be able to get 80% of my work done doing RTK and logging, but I know going into this project I might have 1 or 2 points that I know I'm going to be out of radio range for. So if I know I'm going to be in that position or possibly be in that position, I'll start my survey under an RTK and logging using my external radio. I'll collect the field work I need to do there in close by the base or whatever radio range I can get. And then if I know I have to hit a couple section corners or something further out, I can collect those points rather than fighting radio. I can collect them static and then post-process against the base, turn that vector line blue in TBC, and all that data comes in together real well. So the next one we're going to create is a fast static survey style. And because none of those settings are going to be in common, we're just going to go ahead and create new. All right, let's go ahead and give this a name. This is obviously a GNSS type, not a conventional instrument, and not an integrated surveying. And because we're going to be doing this on the Rover end of things, under Rover options, we can set this to fast static. You will have to pick the correct receiver here, again, because we didn't make any copies from our survey style. Again, your preference, you can put in your HI here. Again, you can always change it, but and then make sure you have your measure to correct. The other thing worth mentioning here, because you're standing right at the rover when you're taking your observation in the situation I described earlier, you can record this one to the controller because you'll be standing right next to the receiver. So here you can do either option. Me personally, I still prefer to log to the receiver simply from the standpoint Bluetooth rarely, but every now and then there's a connection issue. If you log it to the receiver, then you can import it after the fact. It won't delete it from the receiver. I have a backup. So again, your preference here, me personally, I prefer always to log static files to the receiver because I can import them at a later time. The other thing worth mentioning, this needs to be in common with what you're running at the base. I talked about that earlier. So I know if we started our survey in RTK and logging, so we know we're logging a static file at the base. Now we're heading out to shoot that one section corner we know we're not going to have radio on, and we're logging it 1 second at the base. So as I'm driving out there, or once I get out to that section corner, I can hit measure, end survey, so that ends the rover. We leave the base continuing to run. Then I can hit measure this fast static survey style we're creating, which will be connected to the rover. We just want to make sure we're logging at the same interval. So these are the only two settings we really have to look at, other than making sure we put in our correct antenna height and receiver type here. And you'll also want to come down and verify your signal tracking is the same as what you're running at the base. We can hit accept and we can hit store. All right, so the last GNSS survey style I want to run you guys through is a VRS type connection here for the rover, where we're not needing to set up a base. So for this, I am going to take our RTK survey style, and I'm going to create a copy of it, and I can name this VRS or anything you would like. Hit accept here. Now I'm going to come in to edit our VRS survey style. So our rover options, we are going to need to make a change on. This is still RTK. We do need to change the broadcast format. So for those of you here in Colorado or New Mexico, if you're utilizing the Trimble VRS, you guys will want to be choosing VRS parentheses CMR. There are other VRS configurations out there in the country. Utah, you name the state, most of them have some form of VRS capability. There's also some customers who still utilize both VRS and SmartNet, the Leica system. That might be a VRS parentheses RTCM. RTCM is a broadcast format that can be used with almost any manufacturer. But for this instance, we're going to do a Trimble VRS survey style. The one thing other than your broadcast format we're going to need to change, again, we copied our RTK survey style, so everything should be the exact same. The one thing I want you guys to look at here is this store points as. From a legal perspective, you could store these as just positions. This would be the same as just importing a CSV into TBC. You're not going to be getting vector data to go along with it from a legal standpoint. I don't recommend that. I want to store points as vectors. So anytime we're taking observations in the field using VRS, it's going to put up basically a fake base station close to where you're conducting your survey, and all of your vector data from all the points you shoot off VRS will be coming back to this one virtual base station. That's basically determined by this store points as. Again, I'm going to choose vectors here. So those are the only two settings I need to change in the rover options. So instantly when I do that, you'll notice the base settings in here have disappeared. So we are going to have to then make some additional tweaks in Rover Datalink. So this will be going through a internet connection. Our next page down here, or next setting, is going to be GNSS contact. These are going to be your different dial profiles. So before we jump into that, I want to talk about this box here. If you are with a company who has multiple VRS logins, I might recommend having this prompt for GNSS contact. When you go in to your GNSS contact page, you can have multiple dial profiles here, or multiple usernames and passwords on Trimble VRS. So by having this checked, if we leave this blank in our survey style, it will prompt when you go to start measure VRS, measure points. You'll then see a list of all your GNSS contacts, and you'll pick the appropriate one you need for the day. If you only have one username and password, or you've been assigned one you always use, maybe you can have this unchecked and we can just have your exact username, password, and dial profile keyed in here. That might be a little bit confusing, but bear with me. So first thing we need to do after we change this to internet connection is we need to create a GNSS contact. So I don't have any in here at the moment, so we are going to hit new. You can give each GNSS contact name or GNSS contact a name. Most people put in whatever their username is here. So let's say you work for company ABCD and you were given ABCD1 as your username. I would probably key that in for your name for this GNSS contact. Route through controller, we do need to have this enabled. Our network connection is going to be operating system, Wi-Fi cellular. And moving on down the page, we are going to use ntrip. And here's where you're going to put in your username and password. So again, if you're on Trimble VRS, they will email you back, or through whoever who maintains that within your company, they'll provide you the username and the password. It is worth mentioning that both the username and the password are both case sensitive. And again, continuing on with this example, if this is here in Colorado or New Mexico, they will also provide a IP address that you will be dialing into, and they will also give you a port. You don't need to worry about send user identity. For those of you who have used VRS in the past, some of you may have noticed as soon as you connect, you get a list of mount points. We can help you with that a little bit if you know what the difference is between them. This kind of depends on which subscription you have signed up for. You also have the ability to type in your mount point name directly. I prefer to do this. Just it makes things a little bit more plug and play. So I'll go ahead and key this in. So again, with the mount points, depends on which subscription you've signed up for. This is what I'd say most of our customers utilize here. So I can key that in from the get-go just to make things a little bit smoother, less button clicks to get my survey up and running. After I hit accept, it does want me to confirm username and password here is correct, and I can hit store. At this point, I've created a GNSS contact. So this would be a dial profile into Trimble's VRS here for Colorado. And if I do not have the prompt for GNSS chosen, when I hit measure VRS, measure points, it will automatically use whichever username or password I've assigned here under which GNSS contact to dial in through. At this point, if I hit accept and store, I now have a working VRS survey style. Last thing I kind of want to go over here is some of the stuff with either the SX10 or one of your S-Series total stations. I know most of you guys are probably running S-Series instruments, so I'll go in to edit this. Instrument here, which manufacturer? Trimble, obviously here. This is a VX and S-Series. Most of you guys are running robots these days. And you have different tracking modes. Standard tracking is when you're staking out points. And here you can make some tweaks to how many averaged observations are taking place on those. I prefer leaving everything at default. The main thing I wanted to point out in here is auto F1, F2. Obviously, most of our measurements are taking place on face 2. However, when doing a station setup, whether it be with the SX10 or with an S-Series total station, I always prefer to average the observations from both face 1 and face 2. It gives me a little bit more precision from the get-go moving forward. This is something you guys will probably want to experiment with or do some playing, but I absolutely recommend shooting face 1 and face 2 during my station setups. One of the other things some people tend to play with from time to time is set backsight. You can do that via azimuth, or those that want to set that to 0 and typically work in that workflow or fashion. You can always have your backsight to set your 0 angle here, or you can key in your azimuth. So those are the two quick things I wanted to cover. You can come in and change averaged observations for both track mode and standard mode here, but utilizing this auto face 1, face 2 during station setup, obviously I would not want to do this for every topo shot I shoot, but doing it for your station setup does maintain some higher degree of precision throughout your survey, or if there are some errors. We did put out a video on total station adjustment, also kind of covers this face 1, face 2. This would be the auto lock collimation routine, but I prefer to run auto F1, F2 for every station setup I do. It is a quick thing. Recommend you guys do this. And then lastly, if there's something you guys want to change down here regarding your backsight, you can either key in your azimuth or always have your backsight be set to a 0 angle. I don't tweak anything with the backsight centering error or instrument precisions. It knows what instrument it's connecting to. You could go into the spec sheet, so if this is a 3-second instrument, you could come in here and put this is a 3-second instrument and some different tweaks. I prefer to leave this blank. All this can be looked at in TBC anyway. I like leaving that functionality in Office software. So that was the one thing I wanted to cover for the S-Series instruments, and you'll have the same option here with the SX10. So I hope that helps. This will conclude our survey style webinar series for Vectors EDU. Really hope this was beneficial. Know we are going to be putting out a lot more content moving forward. This is a great opportunity for you guys on the weekends, or when you have some downtime. If there's an opportunity for you guys to learn something new, feel more confident in your equipment, we're all for spreading that knowledge and equipping you guys with the right tools out in the field to get the job done. Look forward to continuing to push this out. If you guys have suggestions or maybe a topic you would like us to cover, we'd love to get some feedback from you guys. I appreciate you sticking with me. I know this isn't the most exciting topic, but hope you guys learned something, and we'll see you next time.